This short video is about symmetrical collections. These are collections of pitches that are formed from a repeating pattern of half and/or whole steps. They are known as symmetrical because these patterns are the same forward and backward. 20th century composers really liked using these collections because they worked against the kind of patterns that are present in diatonic collections. The diatonic collection, whole, whole, half, whole, 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 half, for example, which forms a major scale, is characterized by its asymmetry. Symmetrical collections work against this. Since the asymmetry of the diatonic collection means we always can hear where tonic is based on its relationship with other pitches, symmetrical collections make it really hard to hear a center. They are very common in posttonal music. Since the patterns in a symmetrical collection repeat, they have limited transpositions due to the overlap between pitch class collections. French composer Olivier Messiaen described these and other symmetrical collections as modes of limited transposition, which we'll talk about later in this course. There are three symmetrical collections that we'll talk about in this video: the whole tone collection, the octatonic collection, and the hexatonic collection. The first one is the whole tone collection. In this scale, every single interval is a whole step. It sounds like this. We label whole tone scales based on whether they contain C, pitch integer 0, or C sharp, pitch integer 1. Because of the symmetrical construction of the whole tone scale, there are only two possible collections: the one that contains C and the one that contains C sharp. To think about why this is, we could listen to lots of whole tone scales. You've already heard the whole tone scale that starts on C. Here's the one that starts on C sharp. That's a different set of pitch classes. If we start on D now and just move up a whole step for every step of the scale, we get this. That's the same pitches in the whole tone 0 scale that you see on the screen, but they're rearranged or rotated to start on D. When we use pitch integer notation to describe each of these scales, you can see that the whole tone 0 scale contains all of the even pitch class integers, and the whole tone 1 scale contains all of the odd pitch class integers. That's the reason why the whole tone 0 scale is also known as the even whole tone collection, and the whole tone 1 scale is also known as the odd whole tone collection. The octatonic collection gets this name because it has 8 pitches in it. It's a scale with 8 tones. If you're familiar with jazz, you might also recognize this scale by its other name, the diminished scale. Pause the video and think about this. How many diminished triads can you build from an octatonic collection? If you noticed that you can build a diminished triad on every single scale degree of this scale, then you can see where it gets its name. With its interval pattern of alternating whole steps and half steps, the octatonic collection is uniquely suited for generating many triads and seventh chords of differing qualities. Try pausing the video and write a list of all the triads and seventh chords you can build with an octatonic collection. It's a lot. Just like the whole tone collection, the recurring symmetrical interval patterns of the octatonic collection means there are a limited number of transpositions of this scale. In this case, there are only 3 different types: the collection containing the C and C sharp half step in the middle of the slide, the one with the C sharp and D half step on the bottom, and the one with the D and E flat half step on top. Because there are 3 different versions of the octatonic collection, we need to include 2 pitches in the label to differentiate them. Posttonal music theory uses the half step closest to C to make this distinction. Let's hear what these 3 octatonic collections sound like. Here's the Octatonic Collection 01, starting on C sharp. Let's try that one more time, and this time try singing the pitch class integers that you can see below those notes. Again, here's Octatonic 01, starting on C sharp. For that one, you'd say 1, ready, and sing, and 1, 3, 4, 6, 7, 9, 10, oh, 1. Now let's sing the Octatonic 1-2 collection at the bottom of the slide. We'll start on D. 2, ready, and sing, and 2, 4, 5, 7, 8, 10, left, 1, 2. And just so we can sing them all, let's sing the Octatonic 2-3 collection at the top. We'll start with C, or O. O, ready, and sing, and O, 2, 3, 5, 6, 8, 9, left, O. Now, just for fun, let's think back to that Octatonic 1-2 collection that started on D. What if we transpose that whole scale that we just heard up by a half step to get this? It might sound like a whole new scale because now we're starting on E flat, pitch class integer 3. Let's try singing all of the pitch class integers for our new scale. We'll start on 3. 3, ready, and sing, and 3, 5, 6, 8, 9, left, oh, 2, 3. We made it all the way back around to 3. Did you notice which Octatonic collection already on the screen has those same pitches in it? It's the Octatonic 2-3 collection. That's another example of how this collection only has 3 different transpositions. Okay, the Octatonic collection is really cool, and I could probably spend all day talking about its features, but it's time to move on to the last symmetrical collection in this video, the hexatonic collection. Its interval pattern alternates half steps and minor thirds, and because it has 6 tones in it, posttonal music theorists call it the hexatonic collection. Because of this intervallic construction, there are 4 different transpositions, and, like the octatonic collection, we'll label these different transpositions by the half step that's closest to C. With these 4 transpositions, the different collections are labeled O1, the one with C, C sharp, second from the top, 1-2, the one with C sharp, D underneath it, 2-3, the one with D, D sharp at the bottom of the slide, and 3-4 at the top, which has the E flat, E natural half step as its closest half step up from C. Let's sing these, starting with hexatonic 3-4 at the top. We'll just sing the pitches as they're listed in the scale on the screen. So we'll start with C. And we'll sing pitch class integers. So let's sing O for this first C. O, ready, and sing, N. O, 3, 4, 7, 8, left, O. Okay, next one. Hex O1, second from the top, starting on 1. Ready, and sing, N. 1, 4, 5, 8, 9, O, 1. Next up, hex 1, 2, starting Ready? And sing. And 2, 5, 6, 9, 10, 1, 2. And finally, hex 2, 3 at the bottom. 3. Ready? And sing. And 3, 6, 7, 10, left, 2, 3. All right, now that we've heard these scales and learned a little bit about their intervallic construction, it's time to write them. When you're building a symmetrical collection, it's really important to remember the interval patterns so that you can use that to write out the scale. Using integer notation makes this process much easier since you can just add the intervals to the pitch class integers, and, well, you'll see what I mean next. Let's say you wanted to write an octatonic scale starting with a half step and starting on E. You know that octatonic scales alternate whole and half steps. Since you're starting on E, and the first interval is a half step, the next note would be F, a half step up from E. After that, you want a whole step up to G, a half step up to A flat, a whole step up to B flat, a half step up to B natural, a whole step up to C sharp, a half step up to D, and finally a whole step up to E again. This process works the same way when we use pitch class integer notation, but now we can add alternating 1s and 2s to build the scale. So, E is pitch class integer 4, add 1, that makes 5, that's F, add 2 to get 7, G, add 1 to get 8, A flat, add 2 to get 10, B flat, add 1 to get 11, B natural, add 2, mod 12 gets you back around to 1, C sharp, add 1 gets you to 2, that's D, and finally add 2 more to get back around to 4, and that's E. Now let's try writing these scales. You'll need to remember the interval patterns for each of the 3 scale types, and also try both methods, using tonal intervals and using numbers, to get a sense of which one works better for you. Pause the video and try writing these 3 scales. How did it go? Is this what you got? Next, I'll demonstrate writing 2 of these scales using both methods. Let's start with the hexatonic collection starting on F and starting with a half step. And let's use the integer interval pattern for this one. So the first thing you need to do is remember the integer interval pattern for the hexatonic collection. It alternates 1 semitone with 3 semitones. Since the first interval is a half step, that's 1 semitone. We'll add 1 to 5, that makes 6. And the pitch class integer 6 is G flat. Next, we add 3 semitones. 6 plus 3 is 9. And pitch class integer 9 is A. Up next is plus 1. 9 plus 1 is 10. And that is a B flat. Next up is a 3 semitone interval. And 10 plus 3 is 13. In the mod 12 system that we use for pitch class integers, that's 1. Pitch class integer 1 is D flat. And we're nearly done now. Just 1 more semitone gets us to 2. That's D natural. And if we kept going with another interval of 3 semitones, that would make it up to 5, which is F again. Now, let's find a label for our hexatonic collection. We'll use H, E, X since it's hexatonic, and the next step is to find the semitone that's closest to C. This scale doesn't have C in it, but it's about right here. And then moving up from there, the first semitone we get to is this one, the semitone between 1 and 2, D flat and D natural. So this is the hex 1-2 collection. For the whole tone collection, I'd recommend simply memorizing that whole tone collection 0 has all of the even integers in it, and whole tone collection 1 has all of the odd pitch class integers in it. Next, I'll demonstrate the octatonic collection starting on A, starting with a whole step, using that alternating whole step and half step pattern. If you're writing this scale using the interval pattern, the first thing you want to remember is that the octatonic collection alternates whole and half steps. When I'm writing a scale, sometimes I like to use a square bracket to show a whole step. Since we're starting on A with a whole step, I've got a square bracket here, and a whole step up from A is B natural. Alternating the interval pattern, the next one is a half step that gets us up to C. Whole step up from C is D. Half step up from D is E flat. Up a whole step gets us to F. Half step again is G flat. Whole step up to A flat. And then a half step up back to A natural. Now let's write a label for our octatonic collection. It's octatonic, so that gets OCT. And the next step is to find the half step that's closest to C. Here's C. And moving up from there, the first half step we can find is between D and E flat. In integer notation, that's 2 and 3. So octatonic 2, 3 is the label for this collection.